Let's try to finish this activity up before my kid goes nuts. We just left off at number 4, which the time would be -50 if you're going to the year 1850. Okay, so that's just what you're doing. You're going backwards from 1900. What is the linear regression model for this set of data? Number 5. And this is where the calculator is going to come back into play, and I can walk you through all that. So you're going to go to Stat, go over to Calculate. This is a linear regression line, so we are going to go linear regression. L1, L2, we're not going to store it right now. Calculate, and we get our stuff here. Okay, so let me put that over here. I don't think it's going to let me write, no. All right, A plus BX. So I did kind of the backwards MX plus B. It doesn't really matter which one you do. So negative 0.01 plus, and then our slope, which is the B in this case, 10.854. 10.854x. All right, it says to rewrite the equation using words in place of the variables. This is just the men's side. Again, you're going to have to go back and do the women's side, the same exact steps. Okay, so Y was our time, and it is predicted. Big word there. Predicted time is going to be equal to negative 0.01 plus 10.854x. I feel like I missed something there. I got my A and B backwards. What am I doing with my life? Okay. Yep, I got that backwards. Scratch that. Okay. Negative 0.01. Am I doing it backwards again? Yes, I am. 10.854 minus 0.01x. 10.854 minus 0.01 times the year. Okay, so that would be your correct regression equation. Sorry about that, guys. I just didn't want to go start the video over. So, yeah, now something to note here, you have a negative slope. Earlier we also said that we had a negative correlation. Those two things are definitely related. Negative slope, negative correlation, obviously there are connected. Okay, number 6, it says, gives you a little bit of idea about the R, which measures the strength of the association between the years and winning times. The closer it is to 1 or -1, the stronger the association. What is the value of your R? If you do not have an R and an R squared that pops up, here's how you can get it to pop up. Go to Mode, go down to where it says Stat Diagnostics, and make sure that's on. Okay, I gotta go back here and recalculate now. I did option 8. You could also do option 4, it's the same answer. Okay, so my R value is negative 0.89, which is pretty close to -1 because it has a really strong negative correlation. Negative R, negative slope, negative correlation. The same thing would be if it were a positive slope. Works the exact same way. Okay, so again, this is just men's. You're going to have to go back and do women's. It's going to be slightly different, or maybe majorly different. I'm not really sure. All right, number 7. When the relationships between these two variables is strong, the data points are tightly packed around the regression line. A moderate relationship means there's more scatter. A weak relationship means there is a linear pattern, but the data points are widely scattered. Does this appear to be strong, moderate, or weak? I would say strong. There is a pretty strong pull down. You can see a kind of an invisible line that goes almost right through most of those data points. So I would say strong. That's also backed up because our R is negative 0.89. 3 things they're going to look for when you're doing this in stats: strong, weak, or moderate, which we said strong; positive or negative, we said negative; and then is it linear, which it is linear because it follows a line. Those are your 3 parts of the thing they're going to look for, and then context of the problem, which in this case is time. Okay, we might get there in a minute. Okay. Number 8, explain how the values of correlation confirm your answer. If it's greater than 0.8, it's strong. Of course, negative 0.8 is the same thing. If it's, we'll say 0.5, we'll go 0.5 to 0.8, that's going to be moderate. And if it's less than 0.5, my handwriting's terrible, y'all know that, then it's weak. Okay, and this one's strong because it's 0.89. Okay, so it's a very strong correlation. It's negative because it slopes down, and linear because pretty much everything we do is linear in this class. Okay, but you do have to remember to state it because there are other types of correlations. We just don't do them as much. Okay, so that's number 8. Number 9, what is the slope of the linear model for the mean? The slope is negative 0.01. Okay. Which is the one that's multiplied by x, bx, so negative 0.0105. Okay, so that was your slope. And the next thing it says is to interpret the slope in the context of the situation. Okay, and that is going to be as the year increases by 1, the winning time decreases because it's negative. I'm going to say approximately. I like that word better than about. Approximately 0.01. Okay, some key things here. The year is increasing by 1, so you know what our y variable, as our y increases by 1, which in this case is the year, or no, as the x increases by 1, I'm sorry. Yeah, the slope is rise over run. The run is the x. So that's going to increase by 1. The winning time, which is your y variable, is going to decrease because it's negative, and it's decreasing by about 0.01. So approximately 0.01. There needs to be some sort of wiggle word is what we'll kind of call it. Something that shows that it's an approximate. It's not always happening exactly that way, but on average, that's the way it's happening. Okay. This statement right here can be really big on your AP test. And again, this is a question that I would expect you to see on your AP test in the free responses. And if you have this little format down and can take the data and spit this back out, you're going to make a good score on that question. Number 10 is the same thing, but it's asking for the y-intercept, which we already identified was 10.854. That was my y. Okay. And what this means is at year 1900, which we don't know, but we can predict it to be, the predicted winning time is about 10.854 seconds. Okay. Remember, y-intercept is where it crosses the y-axis, so that's where the x value is 0. So when the year is 0, which in this case is 1900, you have to kind of convert that. The predicted, again, we don't know what the winning time is in 1900. All of this is about predicting things. So the predicted winning time is about somewhere in there, 10.854. Okay, so we identified it, and this is the statement again. One of these two questions, I promise you will see somewhere on your AP exam, either in multiple choice or free response. And if you know these and learn them now, the test will be really easy come December probably, and also the AP test will be easy. This should be an easy question on the AP test that you look forward to seeing because you know exactly how to knock it out of the park, and we'll keep working on that. You're just kind of getting a little bit of a taste of it right now based off what you remember from Algebra 2. All right, let's flip over to the back real quick, touch on a few of these questions. We're not going to do but maybe 2 more because they're very similar. Number 11, it says, what do the linear models predict for the winning time in 1964? Okay, well in this case, our x value is going to be 64 because it's 64 years after 0. Okay, and if we want to predict it, we are just going to plug that in to our equation. 10.854 minus 0.01 times 64. And that's what we're going to do. I'm going to quit that, just get it out of there. 10.854. I wrote that down backwards here, sorry. I've had some I'm going to keep doing that. I did that the other day on something kind of important too. Okay, so 10.214 seconds. How do the predicted winning times compare to the data in the table? If you flip on over the table in the year 1964, it was 10.0. The actual was 10.0. The predicted is 10.214. So the predicted was actually higher than the actual time. And that's going to come into play a lot later as well. This is something else we'll talk about with regression a little bit more in depth, is what's the difference between the predicted score by plugging in the equation and the actual score that was recorded, okay? Because those aren't going to be the same. Again, this equation is all about predicting things. I can predict what, the cost of living is going to be in the year 2010 based off what's happened, or 2020 based off what's happened the past 5 or 10 years, but there's a lot of outside variables that can affect that and make it not exactly like you would predict. So anyways, that's what we're doing here, plugging it in, comparing it from the data from the chart. Okay, you have a few more of those questions working on down, 12, 13, 14. Yeah, that's exactly what you're doing. You're just doing predictions. You're just plugging into the men's or women's equation based off what we're doing. Again, we're only doing men's. I didn't do anything with the women's side. You'll have to go in and change your L2 to match up the women's numbers after you've done that, and go from there. Number 17, the x-intercepts. It says, based upon the regression models, the x-intercept of the line is 839.896 for men, which is all we're looking at, and then for women. Explain the meaning and reasonableness of the x-intercept for each line. So basically what it's saying for men is that year, let's see, let me get a calculator real quick. We're looking 839 years into the future. So 1900 plus 839. So at the year 2739, the winning time is 0 seconds. Okay? And the reasonableness, this is not reasonable. The main reason is because it's impossible for the winning time to be 0. It is going to take some time for you to run whatever race we're running here, the 100-meter dash. It's no way that you can complete it in 0 seconds. If Usain Bolt can't do it, nobody can do it. So even though that is a number on the numerical chart, in the context of the problem we're looking at, it doesn't make sense. So it's useless to us. The x-intercept means nothing to us. A lot of times the y-intercept will really mean nothing to you. It will not be reasonable in the data we have. Okay? And that's kind of what they want you to check there. Okay, so where I got this number from was 1900 plus 839. And I just took the decimal off because, half a year, whatever, it's kind of silly. Okay, so that is part 2 of the study of Olympic winning times. You're going to have to go back and do the women's side of things. And answer some questions there, and also you can use the equation we did to answer the other men's questions that we did not go over, like 12 through 17, things like that. All right, again, comment questions in Google Classroom. I'll try to keep up with those over the next few days. And GroupMe, you can use that. Any of those things are great to make sure that you know what's going on and you have this thing done by the first little bit of school. I'll probably make it due the Monday after school starts. All right, guys. Thanks. Bye.